Hello children, so let's do a recap of the formulas of chapter number 1 and solve some questions based on these formulas. So number of atoms in face-centered cubic unit cell is 4, BCC that is body-centered cubic unit cell is 2, simple cube it is 1. And see the formula for A and R. See the formula for A and R where A is the edge length and R is the radius. So you can see for simple cube, A cube is equal to 8R cube. For BCC, R is equal to root 3A by 4. If root 3 value is not given in the question, you have to write it, that is 1.7. For FCC, R is equal to A by 2 root 2. We have the density formula here, Z into M upon A cube into NA. Now D stands for density, Z for number of atoms which I have written over here, M is the molar mass or the atomic mass, A is the edge length, Na is the Avogadro number. So let's solve some numericals based on these formulas. So the first question, calculate the approximate number of unit cells present in 1 gram of gold. Gold crystallizes in FCC, that is face-centered cubic unit cell, and atomic mass of gold is given, that is 197 grams. So when you get such questions, that is finding of number of the unit cells. Number of unit cells. So first write 197 grams is equal to the Avogadro number of particles. Or you can write it as atoms. Always the molar mass, whatever the molar mass or the atomic mass of that substance, it will have Avogadro number of particles, or we can say Avogadro number of atoms, or Avogadro number of molecules, Avogadro number of ions. Correct? So molar mass or atomic mass of any substance is equal to Avogadro number of particles. Now what is given in the question? You have to find unit cells in 1 gram. Therefore in 1 gram, how many particles or how many atoms will be present? So do the cross multiplication. 6.022 into 10 to the power 23 divided by 197. So if you divide this, the answer is 0.0305 into 10 to the power 23 atoms. Correct? So you have found the number of atoms. Now what is the question? Number of unit cells. So we know that in FCC how many atoms will be there? 4. Right? 4 atoms are present in FCC. So whatever atoms you are getting, I got here 0.0305 10 to the power 23 divided by the number of atoms in that lattice FCC. So if you divide, you get 7.64 into 10 to the power 20. And the unit is not there. What you have found is the unit cells. So these many unit cells are present in 1 gram of gold. So any question like this, if it is given, calculate the approximate number of unit cells. That means the first line will be the same. That means you write over here the molar mass or the atomic mass given to you. Correct? So that much of grams will contain, always it will contain Avogadro number of particles or atoms. Therefore, whatever grams given in the question, that will contain how many atoms. So we found that. Then what is given? FCC. Correct. So number of unit cells To find that, you have to divide the atoms, divide by that number. If it is FCC, it is 4. BCC means it is 2. So you get the final answer. So this is one type of sum in solid state. Let's do the next type of sum. So see the next question. 3 elements P, Q and R crystallize in a cubic solid. That means they are crystallizing together in a cubic solid with the P atoms at the corners. Correct. Now imagine one cube. Cubic solid is given. This is a cube. So P atoms are present on the corners. Correct. So where are the P atoms present? At the corners. So I'll write the formula. P is present at the corners means there are 8 corners, 8 atoms, and contribution of each atom is 1 by 8, which is equal to 1. See the next one. Q atoms at the cubic center. Q atom at the cubic center means inside cube's center, that is body centered, right? So Q will be 1. Correct? Body centered only 1. Already we have calculated for the corners. Body centered 1. See the next one. R atoms at face center. That means how many faces it is having? 6 face. So R, 6 face and half. Contribution of each atom will be half because half of the atom will be shared by another unit cell. So that is 3. So we get here the formula of this compound, that is P1, Q1, R3. 1 we are not writing. So the formula is PQR3. So let's check one more example of finding the formula of a compound. So the question is, what is the formula of a compound in which the element Y forms CCP lattice and atoms of X occupy 1/3 of tetrahedral voids? Correct. Now, always the octahedral voids. Octahedral voids, we take it as X suppose or n number. Then tetrahedral voids are always twice of octahedral voids. Always. We are talking of the voids, the empty spaces. Okay. So see the question. Y forms CCP lattice. Element Y. So number of Y atoms. Number of Y atoms. Suppose it is n. Suppose it is n. Therefore, number of tetrahedral voids. Number of tetrahedral voids will be twice of n. Now, X occupy 1/3 of the tetrahedral void. So, X is equal to 1/3 of tetrahedral void, that is 2n, which is equal to 2n by 3. Correct? Now write it in the formula. I'll write as X is to Y. We want the formula of X and Y, correct? When they are forming a compound. So X, I will write it as 2n by 3 is to, what is for Y number of atoms is n. So take the ratio, you get it as 2:3. Therefore, the formula is X2Y3. So what is given to you? Tetrahedral voids are given. So that we will suppose as 2n. Always the tetrahedral voids are twice of octahedral. So it is 2n. So the other element will be only n. or you can write it as small x also. You are supposing. So number of atoms of X is equal to 1/3 of tetrahedral. That is 1/3 of tetrahedral. So you are getting 2/3n. Now take the ratio X is to Y. So X number of atoms we are getting 2/3n. Y is n. Ratio you take, you get the formula of the compound X2Y3.